Hello, everyone, and welcome back to episode 25 of our playthrough of the Artisan of Glimmith. Using nothing but pure logic. 242 puzzles so far. So one of the questions, why a pure logic playthrough? And I really do think not everybody needs to play the game this way, but I think it is important for somebody go through and play the game this way, because I think it highlights the brilliance of the puzzle creators to be able to create puzzles like this that have logical solutions that you don't have to guess. Really does highlight the special talent in puzzle creation. Anyways, that being said, let's jump into this one. We have Rose Windows, we have Gemini, we have Polyomino, and this is going to be interesting here because we have exactly 4 regions. 4 regions. And we can see we have 4 symbols. So this will take. So let's just start with this. This has to come out. Wow. That's not true. It is true. The reason is true. These are 5. This at most could go here. It's not going into this space. This P at most is here. It's not going to that space. So this shape, this cell here is not part of this shape. So it has to have a circle. So all of this is there. This is not part of one of these shapes, so it's going to be one of these up here. So we've already started a process here that we now have a Gemini. These 2 will have to be the same shape. So this is going to come and grow and do some stuff, and this is going to have to come and grow. And this is not the solution, but I'm just showing we're going to have to do, like, everything we do to this side has to be in this side. It doesn't have to be mirrored, but it's most likely it's going to have to be mirrored. Now, this one and this one, these 2 will be part of these shapes. Because this is a different region than this region. Both of these regions need to have this. So, all that to be said, we need these to combine in such a way as to create a symmetrical shape. And these are not symmetrical patterns. So, here's one example. We could do something like that and something like that. And then the rest of the board. This is the solution. This is the solution. But it's not just good enough to get the solution. We have to know this is the only solution, and it is forced. So how can we approach that? So we know that these are separate regions. We know that this circle does not belong to this region. And this circle does not belong to that region. There's no way to connect those together because both of these have to be taken, they would cut each other off. So we can say those 2 go together and these 2 go together, right? That has to be the shape. Now, we do need it to be symmetrical. We do need it to be symmetrical because this shape has to match here. So whatever we do to one side of this, we have to do to the other side as well. So for example, if this went this direction, this would have to go this direction. If this went this direction, this would have to go this direction. We have to maintain symmetry. Now this looks like this could potentially work, and then it would have to go like that to finish the shape out, and then that breaks this shape. So that's probably the best way to do this, is to process of elimination, which pieces can and can't grow. So let's go ahead and look at, can this shape extend past here? Could it go up here? And the answer is no. There's no way to, because it needs both of these, the most it can take is 3. So this has to come out. As soon as this one has to come out, this has to come out. Next question, can anything in this top row be connected to this shape? And the answer is no. So everything in this top row has to be connected to these shapes. Now the question is, could it be, could any of these be part of this orange shape? And the answer is pretty obvious no. But for orange to take either of these, it would literally have to go around the entire outside to get over here, and there's no way that those two shapes are going to match. So anything that takes over here that's not one of these two has to be one of these two. Conversely, that has to go the direction there. So the next question is, could either of these not be associated with their color? Could it be something other than this? And the only way blue, again, we need it to be a mirror image. So once blue takes here, orange would have to take here, but they can't connect, and that region would be broken, so it can't. So and we can't do something like this, because then that's going to break the symmetry as well. So because this can't be part of these regions, this is going to go like that. All right, so let's go down. Let's just go around the edge. Can this be part of the region? And the answer is, for all of these, no. So that means for all of these, no. Can this be part of the region? And the answer is no. So that can't go, and that can't go. All right, now this technically could be part of the region. This one, no, this cannot be. So those, we can shrink it in. We're just shrinking in the shape here. Again, we know what it's going to be, but we're wanting to do like, this is what it has to be. All right, what about, now we're getting into where it's a little trickier. If we do something like this, could this be part of this shape? And for this one, yes, but for this one, no, because this is a W, and the W cannot go back and forth. So for this shape, this cannot be a part. So for this one, it can't be a part either. So let's look at the W for a little bit, because the W does create a little bit of a challenge. First question is, could the W connect? Yeah, is this part, can the W be like this? If it goes there, then this would have to come out here or go there. Neither one of those is valid. So this is not where the W goes. This is not part of the W. So the W is like that. So now the question is, this is not part of the W, so that gets taken. So this gets taken. Since this one is not part of the W, so it is part of the P. So we'll take that. Let's get these at different colors. Right now, where everything's oranges and blues. You guys know I like there to be some color varieties. Okay. Can this be part of the green? No. Doesn't mean it's not part of the purple, though. But we can do this. So if green goes this direction, that would force purple to go this direction. Purple now has to take this one, but this one can't take. So all that to say, this cannot extend that way. Once it can't extend that way, that becomes the case here. Since it can't go that, it does force it down. That is its shape, and this one does have to finish out, and then we just complete the shapes. Hope that was, some of those are a little harder to do with when we're actually going the prove it route. All right, there's one down here that I can see. Yep, we're getting you. We see you down there. All right, we got a 2 and a 2x2. We got deltas, and we have polyominoes. Where do we start? Lots of. So this is going to have to be, the shapes are forcing something like this. It's either that or that. Right? It's one or the other. But this is a 2x2. this is a 2 by 2. This one, can't say much, but that is 2 by 2. That is 2 by 2. So what I'm seeing here is it feels like these are the ones that have the pressure. For example, if this was the 2 by 2, then this would have to be the 2s. Either like that or like this. And the same thing would be true over here. This one has a similar, if it came out like this, then this would have to be a 2 of some kind. Either like that or like that. And then that would have to be a 2. Then that would have to be a 2. This couldn't be a 2, so the 2 would have to be over here somewhere, either down here. These corners are interesting. Let's just say, for example, this was the 2 by 2. Well, that would mean this would be each of these would be the 1 by 2s, and these are both deltas. It would force both of these to come across, and then this would have to be a 1 by 2, but then this could not be a 1 by 2, so it'd have to be the 2 by 2. Then we have to do this. Then this would have to be the 2 by 2. Then this would have to be the 2 by 2. Then this would have to be the 2 by 2. And I think we're running into a contradiction here because both of these have to be 2 by 2s here, and they can't. Isn't that interesting? And all that's from putting this in the corner. And I know that felt like, you know, I was guessing here, but it wasn't meant to be a guess. It was meant to show a problem. The problem here is if we put, and this is going to happen in any of these corners. If we put the square and pull it away, it forces a chain reaction that will collide, because this one's saying this has to be a 1 by 2, this has to be 1 by 2. By the time it gets around, however, you know, if I went out this way and went out this way, it would meet here, or I could have it meet here. It doesn't matter, but the whole point is it's going to collapse because this side has to be the opposite of this one, wherever the pattern goes through. And all that to say that this is going to have to be either like this or like this. It has to be, to force the chain reaction through. So I'm just going to go through it real quick. Let's say it's over here. This has to be different. This has to be a 2 by 2. So this has to be different. This has to be a 2 by 2. Now, again, it can't be the corner one for the same reason we just did. If ever it's in the corner, it's going to create a problem. This is the 2 by 2. This is the 2 by 2. Then this is the 2 by 2. Then this is the 2 by 2. Then this is the 2 by 2. And that works. Now, it could also, this doesn't mean that this is the right answer. It just means that it doesn't create a contradiction like you would if you take the corners. So if any of the corners are a 2 by 2, we're going to create a contradiction. And you can try that out. No matter how you do it, it's going to try to force somewhere. It's going to try to force two 2 by 2s in a box. So this is kind of like a windmill pattern. It's just, whichever orientation it is, it just goes all the way around the outside. We don't know which one it is. But what we can say is that it's deterministic, that it's one of two outcomes. So if this is the outcome, then it's going to force that this is a 2 by 2, 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 this is a 2 by 2. But here's what's important. These are the ones we want to look at. It's these deltas, right? This would have to be a 1 by 2. This would also have to be a, oh, I'm sorry. This has to be a 2x2. This would have to be a 1x2. This would have to be a 1x2. And this is already looking problematic here, but maybe it's not. You can do something like that, and that works. Because if these are so that's one thing. Now, if we go the other direction with it, like this, then this is the 2x2 pattern. This is the 2x2. This is the 2x2. That is, and this is. So now if we look at this orientation, again, these two are the same. This one is different. This one has to be the 2x2. This one has to be a 2x2. And now we've got a contradiction. And this is the break-in. What I'm doing here is this is the way you're supposed to solve this. This is the intentional path. I'm very positive that this is how the puzzle designer is wanting us to discover. They're wanting us to see the interaction between all of these regions, how it forces and how it creates a parity that these two have to have the same shape here, and this one has to be different. So two are the same, one is different. So these two are the same, this one's different. So if these two were the squares, that's a problem. If this one's the square, we can make it work, because that has to be a 1x2, then that has to be a 1x2, this has to be a 1x2, this has to be a 1x2, 1x2, 1x2. So all of that works, and now we can come back here and say this has to be the 2x2, so that's the 1x2. This has to be the 2x2, that's the 1x2, 2x2, 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 not in the corner, 2x2, 2x2, 2x2. Go around here, get all our lines in, and then fill everything else in with the 1x2s. And that is the solution. That is the solution. So two things there. One, identifying that the squares cannot go in the corners. And then two, recognizing the parity disambiguation. That is the crux of that solve. Beautiful puzzle. Beautiful puzzle. All right, we have rose windows, we have Gemini, and we have polyomino. This looks very similar to the one we had before. So once again, these will have to be part of a region. So we know that there's a region here. This region is going to have to take this circle. This region will have to take this circle because they can't take that, and every region has to have a circle in it. So all that to say, that's the start of a region. That's the start of a region. This will take this one. This will take this one. And the shapes that we create have to be mirror images of each other, which is going to be interesting because these cannot combine in any way. So how do we make it that these will be the same? Well, this is what I'm looking at. This is not going to be a mirror like we did before. So this is not going to be, I do this, I do this. Well, I mean, that is true. These regions have to grow, they have to come out. But just because this one grows this way does not mean this one grows that way, because we have these circles here in the middle, which allow us to do some weird rotations. We can do some rotational things here, and I think we're gonna have to, because like this is a S, and let's say this is the L. Like these are not the same shapes. These are not going to be the same shapes, and these have to be the same shapes. And no matter how I do it, oh, here's okay. Here's how we think of it. We've got to use these cutouts. That's what it is. We have to use the cutouts. We have to make our shape using the cutout. So if we do something like this and like this, That creates an F pentomino. This creates an F pentomino. And they're mirror images of each other. And so now we can just literally divide the board in half. Yeah. So it was creating a mirror image. Once we saw that, that is the solution. And I think we can prove that with the idea that first of all, we're not going to create the mirror image is really kind of forced. I was trying to say how we could create a like rotated. There isn't a rotational pattern that's going to work just from geometry. Doing this in any other orientation, what we're saying is if as soon as we say this has to be a mirror image, then we can say this piece, just like this one has to be mirror image and this has to be mirror image. So I have to make this shape take this representational piece over here, which is what this one, and this shape has to take the same piece as that one, which is that, and that does create the space. So all right, let's keep going. Do I do a 5? Let's not do a 5 yet. Oh, these are all 5s. Oh, that's gonna be fun. We got lots of 5s. What's this one over here? A 3. Let's do the 3. Let's go knock out the little ones. Rose windows and Gemini. So we've got the Gemini up here. We've got these down here. How do these grow? This shape here has to grow that direction. This is either this or that. It's not this. Okay, this is good logic. Is this a region? Well, this region can't grow. It can't take another square or another circle. But then that's saying this is also a 2. But no matter how I do that, I can't get a square in it. So this is not a correct space. So this comes down, and as soon as that happens, then that is forced. Now these two come together, but this cannot be the end of the region for the same reason. This has to be at least a length 3 or of some kind. It could be a length 4, but that's about it. Now the question is, could it be a corner? The answer is no. That can't become a corner. So, I mean, unless it gets really big, like something like this. But see, that's a T, that's a L. I'm trying to think, like, is there a way for this one to take this one? And there's no way. Because once this goes out 3, then this one has to be 3. Yeah, and this one can't, this is the most this one could be. Yeah, this can't take that one. It can't be a 2, so it takes this one. That is the shape. Now the question is it this or this? I don't know. This one has to grow. It could connect here. It doesn't have to. What about this? We got the same logic as up here. This can't, if this square grew and took the circle, it can't take any more. And then this one would only be able to do this or this. They wouldn't get a circle. So this is not the origin, and that can't take any more. So that's that. This has to take at least this. It has to grow at least one more. And I think we have the exact same logic here. Can it take this one? Actually, it's not the same logic, because this actually could work in this case. It is a little bit different. This one had the line that prohibited. This one does not. So this could actually be a correct solution, but so could this or this. So we don't know. We don't know how that's going to play out. All right. Could this be a solution? Could this circle take that square? Knowing this has to be a 3, and this is not taking a circle, so it would have to be a 4, and this could not take that. So that doesn't work. So where does this one get its square? If it's not this square. It could be this. It still could be this square, but it would have to be this shape, and this one would have to do that. That's an interesting idea. But if it took this one, because this is the only other square it really has access to, this is now forced. Yeah, that doesn't work. Yeah, it can't take this square, and it can't get to these because there's. So it does have to take this, which means this does have to. This is the shape. All right, this has to come out. It's going to come to at least here. It could grow one more. I don't know, but this one does have to grow. So it does do that. This now has to be the same shape, and it does that. And this one can't grow anymore, so that one can't grow anymore. All right, so we're down to this shape or this shape. If we did this shape, I think this creates a problem for this one. Because it has to be a 3. And that works, but then that orphans that square. And neither one of these could take it. We can say, well, we could do that, and we could do that, and that creates the Gemini, but it breaks this Gemini. So this one, and then it can't go down because that separates these two from each other. So this can't grow that direction. This does have to grow down. And now this one has to connect to this one. This one does have to connect to that one, and they will have to, this has to take that shape. So this one will have to take this to match the shape that has to grow. All right. Got some hidden back here. That's a 5, a 4, and a 4. What are we thinking? Maybe one more 4 here. I went a little long last time. I was really like, oh, I should have stopped that video sooner. But let's do this. I don't want to. I'm trying to keep the videos to just about 30 minutes, give or take. But I also want to pack as many puzzles as I can. Polyomino and rose windows. So we can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 shapes in the puzzle. Or 9 regions. And there are 1, 2, 3, 4, 5, 6, 7, 8 polyominoes. So there's one shape that's not mentioned. We got a total of 81 in here. This is a 5, 5, 5, 6, 6, 6, 6, 5. So actually, let's do the math here. 5, 10, 15, 20. And then these are 24. So that's 44. So there's a region that's of length 37. There's a 37 length. So there's gonna be something like this. I'm just guessing. I'm just throwing this in here, folks. You know, do we get something like that? You know, that goes around the entire outside edge. That's gonna be interesting because these are kind of interesting shapes here. Because this feels like a packing puzzle. Like if I did this whole thing, if I just did this whole thing around 32, that's still not enough. You would have to like come in, you know, something like that. 37 to get 37. And then that's 44, which I believe that's what we counted because there's 4 5s. There's 1, 2, 3, 4 that are 5 length, and 1, 2, 3, 4, 6 length. Yeah. So that's 44. I mean, that is weird. So, I mean, we're going to have some massive shape like this around the edge. I'm not saying it's this shape, but it is some shape like that that's going to take up a ton of space. And then the rest of these are going to have to be packed really, really tight together. So let's look at this shape right here. This one is... I mean, I could do something like if I just draw its shape just like this, that doesn't work. It doesn't take enough. And it doesn't matter how I move this around. I only get one. So this is not center. This is not in the center of the shape. So it has to be offset. But here's the question. I can't offset it up, left, or right, really. Because it starts with a plus, right? It starts with a plus. And I can't, the only way I could shift this is shifting it down like this. And then I have to take one of the corners. So I think that's pretty good logic there. That this is, now I could also potentially make it that like it's like this, like that kind of a shape, but that's the same problem. We only get one of the pentominoes, and if we shift off this way, it's the same thing. And again, I can't shift it like this, can I? Nope. Only get one shape. So even though these are valid rotations and these solve it, they don't allow me to get two shapes into the puzzle, and I can't shift this without running into the other polyominoes. So that being said, I believe we can start with, this is the pattern for this one, and then it's going to take one of the corners. I don't know which one. Let's look at the this guy. These six, I like these six, starting with these sixes because they take up a lot of space. So it could do something like this. That's a valid shape. I think it's going to create problems for this guy right here. Not necessarily, but it could. The other option is doing something like this. I like this better because I think this one's easier to pick up. That doesn't work. That doesn't work. I think this one needs this. This goes with this. And then it's going to pick up one of these two somehow. Don't know which one. Over here we have a U. I think we've got a similar thing going on here. Something like this. Or something. Oh, it only works that direction, doesn't it? How does this pick? I mean, I guess it could go like this. Yeah, those are our two shapes for it to get. Because otherwise we don't get any shapes in it. Either way, these two are together. And it grabs this one or grabs one. And again, I think this one grabs this one. I think this one grabs that one. I think that's the right answer. Let's look at the P pentomino. Simple solution we could do there. Could do something like that. The question I have, does this one take... I think it has to have this one. It has to have a blue and a red, and this is the only blue it can get. So let's connect these two together. Same thing with this this shape here. It needs both a blue and a red, and this is the only red it has access to. So we know that goes there. This one could take this one or this one. And from a packing perspective, it feels like it's going to have to do this. That's what it feels like. But we don't know that. But those two, I think, have to go together. For this cross, it can't have this red one. It looks like we took that one away from this. We've assigned it. So where is it getting its red? It's going to have to be from here. And so the cross cannot go, like this can't be the center of the cross. So this is going to have to be the center of the cross, it looks like that. This needs a circle now. So it's going to grab it from here. This T needs a circle. It's going to grab it from here, but where does it get its square? Not from here. That's too far away. So it's going to grab it from here. And how does that shape get made? I think that's it. That's the only way you can make that shape. And as soon as that one gets taken, this now has to take this one, which is going to force it to have its shape. This one now has to take this. And how will that shape get made? This is the 3. So this has to, it's going to have to take one of these two and this one. And this can't, so it has to take that one. That has to go there. So there we go. This one has to take this shape now. It also needs this one. So that's going to be so this is our shape there. Let's see. This guy needs a circle, so we can now say these go together. We got to make a P out of this. It's not, these go together. So this is all together. I can't make the P that direction, so that's going to go. This needs to be grabbed, so that shape's going to grab it. This U will go around this way, and the rest just goes in the outside. Want a yellowish, don't I? That's okay. All right. Well, folks, that's a great place to stop. We went a little long, but got a lot of puzzles done. Thanks for the support. Like, subscribe, all that good stuff. Hope to see you next time. Take care, everyone. Bye-bye.